Hey, welcome back to Fat Mama Physics. In this video, we're going to be doing multiplying rational numbers. Oh, it took a while to find games to find a game. Well, and I also pigeonholed myself because I'm running out of board games to showcase. I did some of the videos earlier, so I've used a lot of the board games. So I'm stuck with this one here called Bonanza. And I am going to switch over to my phone. Okay, and here we go. Here's that game, Bonanza. It's a game about trading beans, growing your own bean farm, and trading your beans away for money. And whoever gets the most money at the end of the game, of course, is the winner. It's not it's not a complex game. One of the first board games I ever actually played it. I don't play this very often, but might be a good game for someone new to board games. Okay, so here's the basic setup, and I just set it up for 2 players, and there's a lot of things that I didn't actually do here properly. So here's the basic idea of the game. So take a look at our beans, and notice there are different kinds of beans, and notice I have these beans stacked here. That represents a bean field. So notice that in every field, I can only grow beans of the same kind, and so far, I have 2 fields, and every player starts off with 2 fields. You can't have a 3rd field, and if you have to put down a new bean, you have to harvest the bean first, sell it, before you can plant a new one down. Now, the problem with this setup, and usually the part of the game that makes the most trouble for any player, is the fact that you have a hand of which there is a specific order of which you drew it. So if you draw any new card, it always goes at the back of your hand like that, okay? So the rule is, whenever it's your turn, you have to play the card that is first. So notice the order here matters, and so that means I have to play this red bean on my field. And here it doesn't match any of the bean fields that I currently have, meaning I have to harvest one field before I can plant it down. Ideally, that's not really great, because if you take a look at the conversion factor for money, of course, the money gets sweeter and sweeter the more beans that I have on a field. So for example, for blue beans, I have to have 4 blue beans in order to make $1. 6 to make 2, 8 to make 3, and 10 to make 5. A little bit hard to see there. But notice if I try to harvest this field, I'm not even going to get any money off of that at all. So it's going to be pretty bad. So this game lends itself to trading with other players. So notice I have the other player. He's doing really well with his chili beans. He probably doesn't want his blue bean. He might want to trade it away, but I really have to entice him to grab this red bean from me. So there's some trading mechanism in this game where you really have to make the deal worth it for the opponent, and they for you as well. So so the game is, depending on what's in your hand, that might control what bean you want to plant. Some beans are more worth it than others. So let me talk about maybe how worthy is a set of beans. Because notice for every bean, the conversion factor is different. And there's also a number at the top here. And that number tells you exactly how many beans are in the deck. So notice that even though red beans, it looks pretty sweet. Because you don't need a lot of red beans to make a lot of money, and that's because there's only 8 of them in a deck. But is the red bean actually worth it? So this is kind of the time where we get to use a bit of mathematics to figure it out using multiplying rational numbers. Now at this point, I'm gonna kind of show you a little bit of the math that I do, which of course you don't actually have time to do this in a game, but if you could do it, I could take every bean and I could try to figure out how worthy is a bean. So I'm gonna put that away. So I'm gonna put this sheet over here, and I'm just gonna do a little quick demo. Not gonna really go into the details, but just to give you an idea. And I'm gonna compare 2 beans here. Okay, we're gonna do red bean and a blue bean. It's like team red, team blue here. Okay, let me configure this desk a bit so it looks like this. It's a little messy. Alright, so take a look at these 2 beans. I'm gonna leave them right here, actually in front of my text. So here I just kind of, you can totally see how spelling is not my my strength here, why I don't teach English for a very good reason. But anyways, I have a little model here which I could show us, especially with two beans. You notice different ratios are present, and as well as how many cards are in the deck. So when you think about whether a bean is worth it, you got to think about two things. First of all, you want to think about whether or not this conversion is very good or not. Of course, you want the less beans in the field to make you the most money. And that's often case what we like to do. So if I had to find how worthy a bean, how much money a bean is going to be worth or whatnot, I just take the number of coins divided by the number of beans that I need to grow in order to say how much money one bean is worth at a certain conversion, depending how many beans I sell. But also, what's going to determine the amount of money I make is also going to be determined of how likelihood I'm going to be able to draw this bean card from the deck, or how often it's going to show up. Of course, this bean card, even though it's got very nice conversion rates, but there's only 8 of them in the deck. So if I don't draw these cards, they're not going to make me money. As opposed to this blue bean, the conversion rates are a little bit not as nice, but there's 20 of them in the deck. So the worth, I call it the likelihood of making money. It's sort of like a number to represent how likely am I going to make money. If I have a larger number here, it means I'm more likely to make money, and that depends on 2 factors. And the factors is, as you see here, the worth factor. What I call the worth factor is depending on the bean. So if a bean is worth it, that means if I divide the amount of money by the number of beans it requires to grow it, then to make that amount, then this bean is going to make more money, or it's going to be very worth it. For example, for the red bean, I'm going to take, say, let's take take this guy over here. So if I need 5 beans to make me $5, which means if I take $5 gold divided by 5 beans, okay, then that's going to be equal to 1 bean is going to give me 1 gold, okay? So that's the rate, okay? That's the rate there. But is it really worth it? Actually, that's the worth it factor for this one. So that's where the probability comes in. So there's only 8 of them in the deck. When we talk about probability, it's always a ratio of between the number of events that are favorable for us. So 8 cards on the deck are going to be able to allow me to make my full set of red beans. Of course, this number is less now that if I have this card in my hand. So if 8 cards, and let's say I have, say, 100 cards in the deck or something. So I have 100 cards in deck, then this is going to give me kind of the probability that I will be able to draw this card from the deck. So if I multiply these 2 numbers, of course, the larger this number is, the better. The larger this number is also very good for me, and that's going to give me some sort of number. So that's equal to 1 times, and that looks like 8%, which is 0.08 as a decimal. Okay, so that's the likelihood of me making money. That's kind of what I think about it for red bean. So let's quickly do for the blue bean. Okay, so the blue bean, I'm going to take, again, the maximum amount here, which I'm making 5 gold per 10 beans, okay? And that doesn't seem to be really worth it. That's kind of like, basically, I'm making 0.5 gold per bean, okay? That's not very good. But there's 20 of them in the deck, okay? 20 of them in the deck, meaning I'm going to say multiply this by 20 of the events that I like, 20 cards in 100 cards in the deck. So that factor is pretty nice. 20 over 100, if I simplify it, is going to be 1 over 5, which is 0.2 for that matter. So I have 0.5 times 0.2. That's effectively taking a half of 0.2, which is equal to 0.1. 0.1 is definitely better than 0.08. So this is interesting because take a look at the red bean. Even though it seems like it's going to take a little bit faster for you to be able to make some money, but the likelihood of getting in a deck is so low that it may not be worth it compared to something like a blue bean where you have more cards in a deck, even though the rate of making money is not as good as a red bean. So that's something interesting. You play around with math, especially multiplying rational numbers, which we will get back to the lesson. Time to clean the game and see you back. Okay, so here we are back at multiplying rational numbers. You might notice that in front of us is not we don't have the notes. I don't have the notes in front of us. It's something else, and I just want to show you another cool example of when we multiply rational numbers. So decimals, whole numbers, whatever that is, and that has to do with this Drake equation. So if those of you who love science are interested in space and or interested in finding extraterrestrial life forms, this is the kind of the equation telling you the probability or the likelihood of finding life outside of Earth. This here I am on the NASA website, and here we go. Here's the basic idea, which is and the number of wait a minute. Here, so this kind of gets simplified in terms of the number of technological species that have formed over the history of the observable universe. So basically, how many possible different life forms that could exist in the universe depends on a few factors, and this gets broken down into many different things, which I'm just going to summarize as the number of habitable planets in a given volume of the universe. So it's a number of planets out there that can sustain life, times this factor over here, which is the likelihood of a technological species arising on one of these planets. So there's a probability, or there's a chance here, which then depends on so many other things, such as the fraction of suitable planets on which it appears, the fraction of life-bearing planets, the fraction of civilizations that develop technology. So notice that this likelihood factor could be a decimal, a percent, or something of that like. So overall, after we multiply these two numbers, it gives us the expected value of what the chance of us, or the number of life forms that could be out there in the universe. Okay, so another good example of what we do when we of multiplying rational numbers. Okay, because of that, I will probably have to break this video into two parts. So let's do maybe a quick review, and then we will do the first part here, and I'll do example 1 in a very short video coming up next. Okay, so let's quickly do a review here, multiplying fractions. So when we multiply fractions, you know what? It's a lot easier than subtracting or adding fractions, except you do have to convert your mixed numbers into your improper fractions. So for the first example, it's very easy. Okay, there's nothing to deal with there. For multiplying fractions, all you have to do is numerator multiply numerator, denominator multiplied by denominator. Super easy. So essentially this is 3 times 2 over, and the bottom is 5 times 7. 3 times 2 is 6. 5 times 7 is 35. That is multiplying fractions. Okay, and next up we have mixed numbers. Be careful. Whenever you're dealing with mixed numbers, always convert them to an improper fraction. Never try to attempt to multiply, say, 1 by the 4, 2 by the 1. Don't try to multiply those, because the multiplication is more complicated than that. Okay, you can work out a diagram. I can work out a diagram to show you what that is, or you can put in calculators to confirm that is not the case. Always convert mixed number to improper fraction. So let's do this one first. This is 1 times 3 plus 2. This is going to be 5 over 3, multiplied by 4 times 7, 28, plus 1, 29 over 7. We then multiply the top with the top, numerator with numerator. So 5 times 29, this is going to be 5, and then 4 is going to be 145 over 3 times 7, this is going to be 21. This is in simplest form already. We leave it as thus. Okay, next up we have C. Oh, hey, look, there's a hint. Simplify before you multiply. And there's a way to simplify this one. And why would you simplify? Is because it makes your multiplication a lot easier. It saves you a simplification step near the end of the problem. But to be honest, if you forget this, or if you don't see it, or if you miss it, that's not going to be the end of the world, because you still have to multiply numerator by numerator, denominator by denominator, and at the end, if you have a fraction you need to simplify, then that's all you need to do. Okay? So but I'll show you what it means to simplify before you multiply. Okay? So what this means is, if I have to rewrite this whole thing as a single fraction, remember I am multiplying top by top, and I am multiplying bottom by bottom. And if that's the case, notice that I have numbers at the top, numbers in the bottom, separated by this line here, which means division. So any number at the top, if I break it down, that means I can simplify it if I have these numbers here that can be broken down. For example, 14 can be broken down into 7 times 2. Okay? So if I rewrite this is 7 times 5 over 25 times 7 times 2. Guess what here? If I have a 7 at the top and 7 on the bottom, this cancels out. So effectively, I now have 5 on the top, and I have 25 times 2. Oh, wait a minute. I'm not actually done. I just realized something. 25 can also be broken down into 5 times 5. So this is 5 times 5. Okay? So guess what? I have 5 on the top divided by 5 times 5 times 2. I also am able to cross out one of these 5s, which I get if I have nothing on the top. Be careful, that's not 0. That's just 1. Divided by 5 times 2, which is 10. I have now 1 over 10. Well, isn't that easy? Woohoo. So how do we, if we have to go back to the beginning step and just do that in the beginning to make our lives easier, what we could have done was we could have done this. I could have said, okay, divide this 7 by 7. That's just going to give me 1. And I'm going to divide this 14 by 7. That's going to give me 2. Notice I'm cross-simplifying. Okay, cross-simplifying for the two different fractions. Let's cross-simplify for the 5. 5, if I divide by 5, gives me 1. 25 divided by 5 gives me 5. So now I have 1 over 5 times 1 over 2, which is just 1 over 10. So that's a tenth. That's it. So that's just a cute way of simplifying your fraction before you do the multiplication, which then could save you time in the end. Just an option. Last one, we have D, 3 times 7 over 8. This is weird. You might be thinking, where's my numerator? Keep in mind that if you have a number like 3, you can always make 3 over 1. That's a fraction. Because 3 divided by 1 is still going to be 3. That doesn't change my number. Okay, so that's allowed. So guess what? Now I have numerator 3, denominator of 1. 3 times 7 is 21. 1 times 8 is 8. This one cannot be simplified, so we leave it as such. Okay? And guess what? I'm going to end my video here because I'm going to do the rest of this one in the next video. I thank you so much for watching. You already. Thank you so much for watching. See you next time on Fat Mama Physics, multiplying rational numbers, and signing out.